Hello, Hornets. In this video, we're talking about the final task or thing that the AP College Board is expecting you to be able to do with implicit differentiation. And that is given a function that you have already demonstrated that dy dx is equal to, finding the points on the relation where the slope of the tangent line or lines are horizontal. So in the previous video, we talked about vertical. Now we're going to talk about horizontal. And I've given a more difficult problem to work with based upon what we have. So if we're talking about a horizontal tangent line, we know that the slope of the tangent line has to be 0. And in order for the slope of the tangent line to be 0, y minus x must equal 0. Now if that's the case, y must equal x. So if I now know that y and x have to be equal for this specific situation to occur, then I'm going to go back to my original function, x squared minus 2xy plus 3y squared equaling 2. And what I'm going to do is I'm going to plug in either y for every x or x for every y. Now I'm going to go ahead and I'm going to do the x for every y. And then when I do, I end up getting x squared minus 2x squared plus 3x squared equals 2. Now I can easily add these together and find that I'm looking at 2x squared. And if 2x squared is equal to 2, x squared equals 1. And I take the square root and I get two values. X equals positive or negative 1. Now, if that's the case, because x and y are equal, that's what our original statement was, then if x is a 1, so is y. And if x is a negative 1, so is y. And we now have the 2 points on this relation, this ellipse, or this figure, this hyperbola, whatever it is. We'd have to use our determinant to figure that out. B squared minus 4ac and determine what we have. All righty. Thank you very much, Hornets. I suppose I can go a little bit further. Let's do one more thing before I go any further. What happens if I'm trying to find the vertical? See, if I'm trying to find the vertical, I'd now use the denominator, and I would have 3y equals x. And now, wherever I see an x, I'm going to put a 3y. So 3y, the quantity squared, minus 2 times 3y times y, and then plus 3y squared equals 2. I get 9y squared minus 6y squared plus 3y squared equals 2. And you'll notice that as I do this, I end up getting 12. 12 minus 6 makes 6. Y squared equals 2. This is giving me y squared equals 1/3, and therefore y is going to have to equal, as I get all the way down to the bottom, y is going to have to equal the positive negative 1/√3. Now, this is what y is. So then, what is x given y? Well, x has to be 3/√3, and x has to be negative 3/√3. Once again, positive or negative. And now, because I have my x and my y, I can write the 2 points down. If x is 3√3, then y has to be 1/√3. And if x is negative 3/√3, y is negative 1/√3. So just be aware, we can take an equivalence, substitute it into the equation, and then solve. All right. Thank you very much, Hornets. That's enough for this. Be aware you now have everything you need to work on the classwork number 15. Be well, be safe, take care, and we will see you soon. Bye-bye.